Petrochemicals, also called petroleum distillates, are chemical products derived from petroleum. Some chemical compounds made from petroleum are also obtained from other fossil fuels, such as coal and natural gas, or renewable sources such as corn or sugarcane. The two most common petrochemical classes are olefins and aromatics. Oil refineries produce olefins and aromatics by fluid catalytic cracking of petroleum fractions. Chemical plants produce olefins by steam cracking of natural gas liquids like ethane and propane. Aromatics are produced by catalytic reforming of naphtha. Olefins and aromatics are the building blocks for a wide range of materials such as solvents, detergents, and adhesives. Olefins are the basis for polymers and oligomers used in plastics, resins, fibers, elastomers, lubricants, and gels. Global ethylene and propylene production are about 115 million tons and 70 million tons per annum, respectively. Aromatics production is approximately 70 million tons. The largest petrochemical industries are located in the USA and Western Europe. However, major growth in new production capacity is in the Middle East and Asia. There is substantial inter-regional petrochemical trade. Primary petrochemicals are divided into three groups depending on their chemical structure. Olefins includes ethylene, propylene, and butadiene. Ethylene and propylene are important sources of industrial chemicals and plastics products. Butadiene is used in making synthetic rubber. Aromatics includes benzene, toluene, and xylenes. Benzene is a raw material for dyes and synthetic detergents, and benzene and toluene for isocyanates MDI and TDI are used in making polyurethanes. Manufacturers use xylenes to produce plastics and synthetic fibers. Synthesis gas is a mixture of carbon monoxide and hydrogen used to make ammonia and methanol. Ammonia is used to make the fertilizer urea, and methanol is used as a solvent and chemical intermediate. The prefix petro is an arbitrary abbreviation of the word petroleum, since petro is ancient Greek for rock, and oleum means oil. Therefore, the etymologically correct term would be oleochemicals. However, the term oleochemical is used to describe chemicals derived from plant and animal fats. Manufacturing locations. Like commodity chemicals, petrochemicals are made on a very large scale. Petrochemical manufacturing units differ from commodity chemical plants in that they often produce a number of related products. Compare this with specialty chemical and fine chemical manufacture, where products are made in discrete batch processes. Petrochemicals are predominantly made in a few manufacturing locations around the world, for example in Texas and Amp, Louisiana in the USA, in Teesside in the northeast of England in the United Kingdom, in Rotterdam in the Netherlands, and in Jamnagar and Amp, Lahev in Gujarat, India. Not all of the petrochemical or commodity chemical materials produced by the chemical industry are made in one single location, but groups of related materials are often made in adjacent manufacturing plants to induce industrial symbiosis, as well as material and utility efficiency and other economies of scale. This is known in chemical engineering terminology as integrated manufacturing. Specialty and fine chemical companies are sometimes found in similar manufacturing locations as petrochemicals, but, in most cases, they do not need the same level of large-scale infrastructure and therefore can be found in multi-sector business parks. The large-scale petrochemical manufacturing locations have clusters of manufacturing units that share utilities in large-scale infrastructure such as power stations, storage tanks, port facilities, road and rail terminals. In the United Kingdom, for example, there are 4 main locations for such manufacturing: near the River Mersey in northwest England, on the Humber on the east coast of Yorkshire, in Grangemouth near the Firth of Forth in Scotland, and in Teesside as part of the northeast of England process industry cluster. To demonstrate the clustering and integration, some 50% of the United Kingdom's petrochemical and commodity chemicals are produced by the NEPIC industry cluster companies in Teesside. List of significant petrochemicals and the derivatives. The following is a partial list of the major commercial petrochemicals and the derivatives. Ethylene, the simplest olefin, used as a chemical feedstock and ripening stimulant. Polyethylene, polymerized ethylene. Ethanol, via ethylene hydration of ethylene. Ethylene oxide, via ethylene oxidation. Ethylene glycol, via ethylene oxide hydration. Engine coolant. Ethylene glycol, water and inhibitor mixture. Polyesters, any of several polymers with ester linkages in the backbone chain. Glycol ethers, via glycol condensation of ethoxylates. Vinyl acetate, 1,2-dichloroethane trichloroethylene. Tetrachloroethylene, also called perchloroethylene, used as a dry cleaning solvent and degreaser. Vinyl chloride, monomer for polyvinyl chloride. Polyvinyl chloride, type of plastic used for piping, tubing, other things. Propylene, used as a monomer and a chemical feedstock. Isopropyl alcohol 2-propanol, often used as a solvent or rubbing alcohol. Acrylonitrile, useful as a monomer in forming Orlon ABS. Polypropylene, polymerized propylene. Propylene oxide, polyether polyol, used in the production of polyurethanes. Propylene glycol, used in engine coolant and aircraft de-ester fluid. Glycol ethers, from condensation of glycols. Acrylic acid, acrylic polymers. Allyl chloride, epichlorohydrin. Chlorooxyrane, used in epoxy resin formation. Epoxy resins, a type of polymerizing glue from bisphenol A, epichlorohydrin, and some amine. C4 hydrocarbons, a mixture consisting of butanes, butylenes and butadienes. Isomers of butylene, useful as monomers or comonomers. Isobutylene, feed for making methyl tert butyl ether. A monomer, for copolymerization with a low percentage of isoprene to make butyl rubber. 1,3-butadiene, adene, often used as a monomer or comonomer for polymerization to elastomers such as polybutadiene, styrene butadiene rubber, or a plastic such as acrylonitrile butadiene styrene. Synthetic rubber, synthetic elastomers made of any one or more of several petrochemical monomers such as 1,3-butadiene, styrene, isobutylene, isoprene, chloroprene. Elastomeric polymers are often made with a high percentage of conjugated diene monomers such as 1,3-butadiene, isoprene, or chloroprene. Higher olefins, polyolefins such polyalpha olefins, which are used as lubricants. Alpha olefins, used as monomers, comonomers, and other chemical precursors. For example, a small amount of 1-hexene can be copolymerized with ethylene into a more flexible form of polyethylene. Other higher olefins, detergent alcohols, benzene, the simplest aromatic hydrocarbon. Ethylbenzene, made from benzene and ethylene. Styrene, made by dehydrogenation of ethylbenzene, used as a monomer. Polystyrenes, polymers with styrene as a monomer. Cumin, isopropyl benzene, a feedstock in the cumin process. Phenol hydroxybenzene, often made by the cumin process. Acetone, dimethyl ketone, also often made by the cumin process. Bisphenol A, a type of double phenol used in polymerization in epoxy resins and making a common type of polycarbonate epoxy resins, a type of polymerizing glue from bisphenol A, epichlorohydrin, and some amine. Polycarbonate, a plastic polymer made from bisphenol A and phosgene solvents. Liquids used for dissolving materials. Examples often made from petrochemicals include ethanol, isopropyl alcohol, acetone, benzene, toluene, xylenes, cyclohexane of 6-carbon aliphatic cyclic hydrocarbon, sometimes used as a non-polar solvent. Adipic acid, a 6-carbon dicarboxylic acid, which can be a precursor used as a comonomer together with a diamine to form an alternating copolymer form of nylon. Nylons, types of polyamides. Some are alternating copolymers formed from copolymerizing dicarboxylic acid or derivatives with diamines caprolactam of 6-carbon cyclic amide. Nylons, types of polyamides. Some are from polymerizing caprolactam nitrobenzene, can be made by single nitration of benzene aniline, aminobenzene methylene diphenyl, diisocyanate, used as a comonomer with diols or polyols to form polyurethanes or with dipolyamines to form polyureas. Alkyl benzene, a general type of aromatic hydrocarbon, which can be used as a precursor for a sulfonate surfactant. Detergents often include surfactants types such as alkyl benzoate sulfonates and non-alphenol ethoxylates. Chlorobenzene, toluene, methylbenzene, can be a solvent or precursor for other chemicals. Benzene, toluene diisocyanate, used as comonomers with polyether polyols to form polyurethanes or with dipolyamines to form polyureas. Polyurethanes. Benzoic acid, carboxybenzene, caprolactam, nylon, mixed xylenes, any of 3-dimethylbenzene isomers, could be a solvent but more often precursor chemicals. Orthoxylene, both methyl groups can be oxidized to form phthalic acid, phthalic anhydride. Paraxylene, both methyl groups can be oxidized to form terephthalate acid. Dimethyl terephthalate can be copolymerized to form certain polyesters. Polyesters, although there can be many types. Polyethylene terephthalate is made from petrochemical products and is very widely used. Purified terephthalic acid, often copolymerized to form polyethylene terephthalate. Polyesters. Metaxylene isophthalic acid. Alkyd resins, polyamide resins, unsaturated polyesters.